The values we've been adding so far are referred to as scalars. Scalars are quantities that are described only by a number that tells us the magnitude. That includes speed, temperature, mass, length, area, volume, work, power, energy, density, pressure. The list goes on. Vectors, on the other hand, are quantities that are only fully described if we provide both the magnitude and the direction. Vectors include velocity, displacement, acceleration, momentum, force, lift, drag. You get the idea. Since vectors have both magnitude and direction, we can describe them by drawing arrows. When writing vectors, we usually name the vectors using a capital letter and draw an arrow over top. In type, you may also see these simply as an uppercase letter given in bold. Both indicate that we're to expect two different pieces of information that will describe this vector, the magnitude and the direction. We can add vectors by drawing pictures of these vectors. So here we have vector A and vector B. Normally when we add two numbers, we just add them up. We reach for our calculators if they're bigger, but it's fairly straightforward. Here we have to consider that they're also pointing in different directions. Essentially, when we add scalars, it's like adding two vectors that are pointing in the same direction. There are two different ways to draw the addition of vectors. Of course, we'll also look at this algebraically, but we want to make sure that we can draw this as well so that we can approximate our answer. We can estimate our answer. So to add vectors, we simply start with one of them. Start with either vector A or vector B. I'll draw that here. There's an approximation of vector A. Where vector A ends, I'll now start drawing vector B. I'll place the tail of vector B. There's vector B. The sum of those two vectors we call the resultant, vector R, and it looks like this. The resultant simply starts at the start of vector A and ends at the end of vector B. Essentially, it's saying, great, so you took this long journey, you walked kind of northwest for a while, and then turned around and walked southeast. I don't really care how you got there, but the vector, the resultant vector, tells me where you ended up relative to where you started. It's essentially taking the shortcut. It doesn't matter if we start with vector A or with vector B, and it doesn't matter how many vectors we add. We can add as many vectors as we want using this technique. Another way to draw the addition of vectors is to use the parallelogram method. Really, use whichever is more convenient in a given situation. For the parallelogram method, we're going to draw the two vectors tail to tail. So here's vector A. And now instead of starting vector B at the tip of vector A, I'm going to place them tail to tail. Vector B looks roughly like this. So having placed vector A and B tail to tail in this way, I now am going to use those two sides to draw a parallelogram. Remember that a parallelogram is a shape that has two pairs of vertical sides. The top and the bottom are parallel, as well as the same length, as are the left side and the right side. So if these are two sides of a parallelogram, let me sketch in the other two sides. Now that I have my parallelogram, the resultant vector starts where the two tails of my vectors meet and then is the diagonal of the parallelogram. These are only sketches, but the resultant I've drawn on this slide should be the same magnitude and in the same direction as the resultant I drew on the previous slide, where I added the same two vectors using the polygon approach. We often use the parallelogram approach when we're drawing vectors on a coordinate plane. It's easy for us to draw the vectors with all of them starting at the origin. The downside of the parallelogram method is we can only add two vectors at a time. If we wanted to add a third vector, we would now take the resultant of A and B and use that to start adding our third vector. We can also draw the subtraction of vectors. Subtracting vectors is quite easy. In the same way that algebraically, subtraction is really just the addition of a negative number, here we're just going to take our vector, flip it 180 degrees to give the negative version of that vector, and then add those two vectors together. So in this case, let's take vector A and subtract vector B. In order to do that, we'll draw vector A, and then we'll consider negative vector B. Well, if this is positive vector B here, then negative vector B has the same magnitude as positive vector B. It simply points in the opposite direction. So now we'll take our vector A and add negative vector B. I'll use the polygon method here. Here's a picture of negative vector B. What does the resultant look like? Here's our resultant using the polygon method. So this is vector A, the resultant of vector A minus vector B.